Assalamualaikum. Saya Hafizuddin. Ingin membentangkan mini project punya demo video tajuk Digital Clock. Projek ini disiapkan bersama rakan saya iaitu Azim Zamriza dengan Syakir. Kami bertiga daripada Group 2. Kita teruskan. Untuk introduction, this project involves building a digital clock by combining two main areas of electronic, such as analog transistor and digital logic. The goal is to create a system that takes a simple electrical pulse and turns it into a clear display of hours, minute and second. Problem statement. Common digital clock often have two main problems, which is they lose time because of internal delays, or we call it propagation delays, and they become unstable or break when they get too hot. If the transistor aren't set up correctly, high temperature like 75 Celsius above can cause the display to flicker or the parts to fail. So this project aims to solve this issue by designing better clock that use precise maths and logic to stay accurate and stay cool under pressure. The purpose of this project, as we can see, to develop a digital clock that is able to display time, hours, minute and second, using modulus counter and sequential logic circuit. The project aims to demonstrate how different digital component can work together to perform accurate time counting. We can see the result on the 7th segment. In the end, student can better understand the practical application of digital logic design and counter-based timing system. Objective, as we can see here, to design and implement a digital clock system that can accurately display hours, minute and second by using modulus counter, such as modulus 10. It will count from 0 to 9 and reset. Modulus 6, same, from 0 to 5 and then reset. And lastly, modulus 3, 0 to 2 and reset. Often used for hours 10 digit in 24-hour clock. As we can see, there are some activities we did before this. During the lab, we apply what we did on the circuit by using Altera board. Also, we finishing on the middle picture is what we do is we finishing our circuit on quarters. The last picture is we are trying to figure out what we did wrong. In the end, we solved the problem and managed to get the thing done. Here we can see modulus 10 state diagram. PSNS table for modulus 10, JKFF table, K-map, equation for modulus 10. Modulus 6 state diagram, PSNS table, JKFF table, K-map, equation. Modulus 3, the last one and simple. We can see PSNS table, K-map and the equation.
Seven four four seven. The clock input will produce a clock signal that is sent to the counter to start counting time. The counter will count in form of binary number and is used to count second, minute, hour in a digital clock system. In this circuit, there are several types of modulus counters, namely Mosfet, 6, and 3. Mosfet counters are used to count from 0 to 9. For example, used for second or many digits. Most software count from 0 to 5, which is usually used for tenth of a second or tenth of a minute. Meanwhile, mostly counters count from 0 to 2, depending on the specific address in the counting system. Logic gates are used to control the reset process, so that the counter returns to 0 after reaching the count limit for each model. The output the output from the counter is then sent to the table for table decoder, which converts the binary number into the signal for the table segment. The demonstration shows the counting of the turns, minutes, and hours. We have also add fast forward button and stop time button.
Also, we add some features which is time skip and time stop. Time skip is referred to reset logic that force the counter to skip higher number and return to zero. While time stop is when you have the control to stop the time from continue counting. These features can be seen on the board, which is what you saw on the video before this. Weakness is same as I said earlier. We have two main weakness, which is heat sensitivity and time glitch, or people we call it propagation delay. In conclusion, this project successfully show how to build a working digital clock by combining analog transistor and digital logic. By carefully setting up the 2N3904 transistor, we ensure they could handle the heat up to 75 Celsius without failing. We also proved that using a chain of modulus 10, modulus 6, and modulus 3 counter is an effective way to turn a simple electrical pulse into accurate hours, minute, and second. The project demonstrates that a well-designed circuit can stay stable and reliable even in real-world conditions. I don't think so. There's a question. Thank you. That's all from me.